Hello, my name is Steve Bowler, and welcome to the Juniper Border Gateway Protocol, BGP Lab number 5. In this lab, we're going to take a look at the BGP attribute known as AS Path. In particular, we're going to take a look at AS Path Prepending. So the first thing I want to do is explain our current network topology that we have. We have 6 routers, router 1 through router 6. All of these routers are logical systems within one physical Juniper router. And what logical systems allow us to do is break down the physical router and create virtual routers within one physical router. And then we can go ahead and connect all these virtual routers together using what's known as logical tunnel interfaces. If you're not familiar with logical systems, I would recommend that you go back and watch my logical systems videos in which I explain in detail how to configure them. So all the links between the routers are logical tunnels, and all the logical tunnels equal lt-120.xx. So for instance, on R2, the link between R2 and R4 on router 2 is lt.24. That's been shortened. It's actually, the interface is lt-120.24. So we have 2 main autonomous systems in this network diagram. We have autonomous system 100, which is router 1, router 2, and router 3. And then we have autonomous system 200, which is router 4, 5, and 6. On router 1, we have a loopback 0.1 with the 1 and 11 networks attached, both /24s. Between router 1 and router 2 is the 12 network. Between router 1 and router 3 is the 13 network. All of the IP addressing for the interfaces are as follows. Router 1 is the .1s, router 2 is .2, router 4 is .4, and so forth. The link between router 2 and router 4 is the 24 network. The link between router 3 and router 5 is the 35 network. Router 4 to router 6 is the 46 network. And router 5 to router 6 is the 56 network. So we're going to be using this network topology, this network diagram, for the next couple of BGP labs as I explain and go over some of the BGP attributes. In this lab, we're going to take a look at how to perform BGP AS Path Prepending. And router 6, if we take a look at router 6, it also has a loopback interface on it, loopback 0.6, where we have the 6 network and the 66 network. Both of those /24s. All of the IP addressing and all the interfaces have already been pre-configured. If not, this video would take me forever to configure and present to you. So in Autonomous System 100, router 1 is, you might be asking, well, what does RR stand for? That is, if you were with us with the last BGP lab, that was BGP Lab 4, where we looked at the basics and introduced you to route reflectors. So router 1 is going to be a route reflector in Autonomous System 100, and router 6 is going to be a route reflector for Autonomous System 200. Just a real quick summary of a route reflector. What it allows us to do is bypass the rule of that your iBGP neighbors must be a full mesh. So obviously in this scenario, router 2 and router 3, we are not running an IGP or an interior gateway protocol in this video at all. We're just running BGP connections all the way around. So router 2 and router 3 not connected, and there is no interface or no connection between them. They are not peering via IBGP. So router 1 peers to both of these routers, router 2 and router 3. So that's why we made router 1 the route reflector. Same with router 6. Router 4 peers directly with router 6 via IBGP. Router 5 peers directly with router 6 via IBGP as well. And router 6 is going to be the route reflector and reflect the routes that it learns. And there is 2 external BGP connections in this video. One of them is between router 2 and router 4, and the other one is between router 3 and router 5. So we all know, and you should know by now, that BGP uses the AS Path for loop prevention and also to find the best path through the network. So the shortest path, BGP is a path vector protocol, meaning that it's going to try to take the shortest path to reach the destination. With that being said, there may be times when you need your link to be one of your links. In this case, we have from Autonomous System 100's viewpoint, it peers to Autonomous System 200 via external BGP in over two different connections. And what we're going to do in this video is we're going to advertise our loopbacks what I meant to say is that we have already advertised our loopbacks into BGP. So router 1 advertising the 1 and the 11 network into BGP, sending it to Autonomous System 200 via the 24 external BGP connection and the 35 external BGP connection. Also router 6 doing the same thing. It is advertising via a simple routing policy the 6 and 66 network into BGP and sending it to Autonomous System 100 via the 24 network link and the 35 network link between router 3 and router 5. So the first thing I want to show you is that if we go to router 6 and do a show BGP show route protocol BGP. From router 6's viewpoint, we have the 1 network and the 11 network learned via BGP, and the preferred path is through a router 4 for both of those networks. Now we can use AS Path Prepending inside of Autonomous System 100. We can prepend our autonomous system, which is 100. We can prepend that, meaning we can make it look like we are farther away and make the path from router 6, router 4, router 2 to router 1 not the preferred path for router 6 to take. Because right now, if we look at a trace to, not to the 6 network. If we do a trace route to the 1 network, 1.1.1.1, source it from the 6 network, the path that it's taking is from router 4 to router 2 to router 1. And so it is important for us to remember that by controlling the AS Path Prepending, what we're able to do is influence the way that other autonomous systems will be able to reach us. So we can make it look like we're farther away from 1 link, and so that the traffic from Autonomous System 200 will then prefer the second link. And that's what we're going to see in this first example, is that we're going to prepend on router 2. We're going to make it look like we're farther away by setting up prepending. We're going to set that up because external BGP uses AS Path, the shortest AS Path, as the best way to reach the destination. And what we're going to find is that the path through router 5, router 3 to router 1 is indeed the best path. Let's go ahead and set up trace options within BGP. If you're not familiar with trace options, I have a video on how to do that, how to set it up. And real quick, what it's used for is it's kind of like doing a debug on a Cisco iOS device or a Cisco router. The trace option will allow us to name a file and then log all of the real-time events that are occurring to that file, so we can go back through and take a look at some of those important events. Very simple to set up. I'm just going to go under Set Protocols BGP, then do Trace Options, and we'll just call this BGP Lab. Let's see, this is BGP Lab 5, right? Yeah, BGP Lab 5 R6. Then under that we'll do, I'm sorry, forgot the file option. Then we'll go Set Protocols BGP Trace Options flag. If we do a space question mark, we have a lot of different things that we can catch and send to our file that we just created. We'll just send all the events to our file. We'll go ahead and start that on router 6. On router 2, I'm sorry, on router 1. First, let's log into the logical system. We do that with set CLI logical system R1. That's the command to log into the actual logical system itself. We'll go under and do the command set protocols BGP trace options file BGP Lab 5 R1, and then we're going to flag all events. So we're just going to set that up real fast. That way, before we start doing anything, excuse me, we need to set that up for when those important events come in. I want to show you some of those in detail. So if I do a show route on router 6, we look back at our network diagram. Router 1 is advertising the 1 and 11 network to router 2 and router 3 via IBGP, and then the 1 and 11 network is being sent via external BGP via the 24 network and the 35 network to router 4 and router 5 in Autonomous System 200. So right now we're just trying to determine the best path that is being taken from router 6's viewpoint to reach the 1 and 11 networks. If we do a show route on the 1.1.1.0/24, do a detail, the preferred route is via router 4. It appears as router 5 is not being chosen, and that is because it's not the best in the group because of the router ID. Again, on R6, if we trace route now, let's do a trace route to the 11 network, source it from the 66 network. That traffic going from router 4, router 2 to router 1, we trace from the 1 network, source it, trace to the 1 network, source it from the 6 network. We can see that it's taking the same path. If we look at our trace option file, we'll do a show log OSPF R5 OSPF Lab 5 R6. I'm sorry, why did I put in OSPF? Show log BGP Lab 5. All of you out there probably think I'm crazy. I apologize. I have not been drinking. So show log BGP Lab 5 R6. And as you can see, we get a lot of information. So we want to do a match so that we can further isolate down to the specific events that we want to see. We'll do a show log, then the log name, and then we'll just match on the one network, 1.1.1.0. Let's go back in the log. Oh. So it appears as though it's not showing up in the log. Let's do this. We'll do a clear BGP neighbor soft inbound. And now let's see if we can find that. Well, we might have to do a hard clear on the neighbor. Let's do this. Let's give it a second to let the BGP, we'll let BGP reconverge and update. Don't think it'll happen that fast, but we can look and see. Just to show BGP summary. You still see the state is active. We all know that's bad news when you're talking BGP. And there we go. So let's do show log BGP Lab 5 R6. And this is exactly what I wanted to show you. So some good information that we are getting is that our gateway that is being chosen is router 4, which is 46.46.46.4. You can see that's the active path. The gateway, which is router 5, 56.56.56.5, is coming up as not the best. So going back to our network diagram, right now the path router 6 is taking is the top path, which is through router 4, router 2 to router 1. And so say we are administering right now Autonomous System 100. We want to make sure that traffic from Autonomous System 200 enters Autonomous System 100. We want to make sure this traffic enters through the connection between router 5 and router 3. One of the simplest ways to do this is to perform AS Path Prepending on router 2 to make it look like the path from Autonomous System 200's viewpoint is a lot farther away than it actually is. We can do that by prepending our autonomous system multiple times, sending that update via external BGP to router 4. And then that update will be sent to router 6. Router 6 is the route reflector. It's going to reflect that information to router 5. So what we should see is that router 6, by the time it receives this, it's going to have to make a decision on what is the best way to reach the 1 and 11 network after our prepending is done. And we're going to take a look at that in detail. Let's go to router 2. what we're going to do is we're going to create a simple routing policy on R2 to prepend Autonomous System 100 and send this information via an export policy to our external BGP peer, which is router 4. This is actually very simple to do. We'll take a look at how to do this the simple way first, and then we'll take a look at a more advanced way to do it. First, we're going to create our routing policy. We'll do edit policy options, policy statement. We'll just call it prepend. Term 1. Then, if we do a space question mark, we have the option for AS Path Sorry about that. We first have to go under our routing policy, so we'll do edit policy options, policy statement, prepend. So now that we're under that level in our hierarchy, now we do the command set term 1 then, and now you can see that we have the option for AS Path Prepend. So we'll do the command set term 1 then AS Path Prepend, using quotation marks. We're going to put in our autonomous system. So we'll put in quotation mark 100 space 100 space 100. We'll just put it a couple times, or several times I should say, 5 times. Then another quotation mark. So that's it. It's that simple. Our routing policy is created. If we do a show, we can see that we just have one term, term 1, which is giving us the action, then AS Path Prepend 100, 100, 100, 100, 100. Then the last thing we need to do on router 2 to get this sent to router 4 via external BGP, we're going to have to export this. We'll do edit protocols BGP. If we do a show on router 2, we have group eBGP, which is external, and this is to Autonomous System 200 via router 4. We'll do the command set group eBGP export, and then we'll just put in our routing policy that we just created, which is called prepend. So we'll go ahead and commit that on router 2. And if we go to router 6, give us a little space to see what's going on. If I do a show log and match on the 1 network, what we see right away is that the gateway is now router 5 is active, and we see the path to router 4 is inactive. If we go ahead and take a look at one of those routes in detail, we'll just do a show route 1.1.1.0/24 detail. On R6, we see that the path is router 5. The state is active. The AS path is 100. And we can see the connection from router 4 is inactive because of AS path. And if we look at the AS path that we're getting from router 4, we can see that it's much longer than the AS path that we're receiving from router 5. So therefore, router 5 is going to win because it has the shortest path. Another good command we can use on R6 to see some information, some good information, is show route protocol BGP terse. This is showing us the networks that we're learning via BGP, we can see that we are receiving from router 5 the 1 network. The AS path is 100, whereas from router 4 we're seeing the AS path of 100, 100, 100, 100, 100, 100. Same thing with the 11 network, and that's because of the AS Path Prepending that we performed on router 2. The last thing we want to do to confirm that the path is now being taken, which is router 5 and router 3 to router 1, would be trace route 1.1.1.1. We'll source this from 6.6.6.6, and we can see that it is now using the lower connection, which is between router 5 to router 3. Let's look at that trace route. We'll do that on the 11 network, source that from our 66 network, and we've seen the same path being taken. So that's it. That's our first example of AS Path Prepending. What we did was we set up on router 2 a simple routing policy. Let's go back onto router 2 and look at that. We do a show. Let's go to the top. Do a show. We created a simple routing policy called prepend, in which we just had the action of setting the AS Path Prepend, and we set it 5 times for 100. Then we exported that via our eBGP, and those updates were now being sent to router 4 saying, hey, the path through me is going to be 5 hops. Router 4 saw that and updated router 6 with that information, where we saw router 5 only was being given the path of 1 hop or 100. So there was only one 100 being sent between router 3 and router 5, whereas between router 2 and router 4 there was actually 5 100s, if that makes sense to you. And what we saw as a result is that the AS path came into consideration, and the shortest AS path obviously was the winning factor, and that's why we saw the traffic reroute to router 5 to router 3 to router 1. So that was our simple AS Path Prepending example. Let's look on R1 and see how the routes are making it to the 6 and 66 network. We do a show route BGP, or show route protocol BGP. We have the 6 and the 66 network. It looks like they're both coming in from R2. We do a show route protocol terse. I'm sorry, show route protocol BGP terse. The AS path from that Autonomous System 100 sees, or from router 1's perspective, it sees 200 for both connections between router 2 and router 3 for both of the networks, the 6 and the 66 network. We do a show route on the 66 network from R1. Let's do the show route detail. The next hop is router 2. The inactive reason that router 3 is not being chosen is that it's not the best in its group because of the router ID. Let's go ahead and do some traces. Do a trace route 6.6.6.6. Source it from the 1 network. You can see that it's taking the path R2, R4 to R6. You should see the same behavior for the 66 network as well. And that is exactly what we see. So we see the 12 network, the 24 network to reach the 6 network. That is, so it's taking router 1, router 2 to router 4 to router 6 to reach the 66 and 6 network. So what we're going to do in this scenario is we're going to set up AS Path Prepending within AS 200, and we'll do this on router 4. We're going to prepend the 66 network so that the path preferred from router 1 to reach the 66 network is going to be from router 1, router 3, router 5 to router 6. But for all other networks, in this case the 6 network, we will see that it will still be reachable from router 1 to router 2, router 4 to router 6. So from Autonomous System 200's viewpoint, we are in a sense performing some load balancing. We're allowing Autonomous System 100 to reach the 66 network. It's going to go between router 2 and router 4, whereas to reach the 66 network, it's going to take router 3 to router 5, whereas the 6 network is going to go through the connection between router 2 to router 4. So let's go to router 4. First we're going to create our simple routing policy. We'll do edit, policy options, policy statement. We'll do prepend. Then we're going to do set term 1 from route filter 66.66.66.0/24. Exact. So it's going to be an exact match on the subnet mask. So we'll do set term 1 from route filter matched on the 66 network exactly. And then our action is going to be set term 1 then AS Path Prepend quotation 200, 200, 200, 200. So let's go ahead and commit that. And then what we'll do on router 4, we'll go under Edit Protocols BGP. Do the show command. We see that we have internal and external groups set up. We're going to advertise this in our external BGP connection to router 2. So we'll do the command set protocols set group eBGP export, and then we're going to put in our routing policy that we just created, which is prepend. Let's go ahead and commit that. And if we go back to router 1 and do some show commands, we do a show route protocol BGP we see for the 6 network, we see the path that is being taken is through router 2, whereas for the 66 network, we now see the best path is through a router 3. We do a show route protocol BGP terse. The 66 network has the AS path of just one of the just 200 in its AS path through router 3, whereas through router 2 we are now seeing 200 5 times. So obviously, remember, AS path, we're looking for the shortest AS path to win the election of having the best next hop, and that is one from router 3. And that is because on R2 what we did is we created a policy, a routing policy. I'm sorry, not on R2. On R4 we created a routing policy. Let's do this. We'll do a show. We created a routing policy called Prepend, in which we had a route filter match the 66 network exactly, and then we just prepended that network 4 times. And that was the only one. So that's why if we go back to router 1, we still see the 6 network coming in and having router 2 as the best path. On R1, if we do a show route 66 on the 66 network, it's being preferred through router 3. Router 2 is not winning. It's inactive because of the AS path. Obviously, we see that its AS path is a lot longer than we are receiving from router 3. So on R1, if we trace to the 66 network, source it from the 11 network, the path that it's taking is the 13 network, the 35 network, to the 66 network. So that is the link between R1 to R3, and then R3 to R5, and then finally to router 6. However, if we trace to the 6 network, source it from the 1 network, the path that we're seeing for the 6 network is 1224 to the 6. So that's going router 1 and router 2 to router 4, and then to router 6. And just for fun, if we want to ping, let's just do simple ping. It shows that we have reachability. Could also do rapid count of 100. Oops. Forgot to source it. 1.1.1.1, and we have reachability. To the 6 network and to the 66 network. So that's it. That's Juniper Border Gateway Protocol BGP lab number 5. In this lab we took a detailed look at the AS Path Prepending. We set it up on router 2 for all of our networks to be prepended within our autonomous system. We sent those updates to router 4. As a result of the prepending from router 2 to router 4, the AS path was seen as being higher if router 6 would have gone to router 4 to router 2 to reach router 1. So what we saw is on R6, when we did our traces, the path became active between router 5, router 3 to router 1. And then in our last example, what we did is a little more detailed approach within our routing policy on R4 in Autonomous System 200. We just matched the 66 network exactly, and we prepended just that network to router 2, which was in Autonomous System 100. What we saw as a result on router 1 was that when we did a trace to the 66 network, the path was to router 3 to router 5 to router 6. Whereas the trace to the 6 network was still going router 2, router 4 to router 6. And that's because within our routing policy we just matched the 66 network and that was it. All other traffic was going the normal route. So I'd like to thank you for watching, and I hope to see you in the next video.